Mainly, I will be focusing on integration testing, especially with respect to the object-oriented concepts. So how exactly the methods are getting executed from one after the other, creating a stub will become a tedious task is what you need to observe in this diagram, right? How exactly the message is being sent across the different classes that I have in the system. Hello everyone, I welcome all of you to the very interesting session, especially guys, object-oriented integration testing. So what exactly that we have here? So guys, this is going to be the first chapter in your unit 4 is what you need to remember before I start this chapter. So guys, what exactly I will be discussing here? Mainly, I will be focusing on integration testing, especially with respect to the object-oriented concepts. Yes. Without wasting much of your time, let me get into the session. Guys, I will be discussing the UML support for integration testing is what I would like to tell you all in this session. Along with that, I will also discuss the MM path. So how exactly MM path is involved in the object-oriented software is what I will be discussing. But guys, this topic, what I have, the last topic, I will be discussing this in the very special session that is more important. That's why I wanted this session or this concept in this agenda part, because please remember I have 3 main topics in this session. So fine, without wasting much of your time again, let me get into the session. What exactly I have? You all please remember UML defined object-oriented software and the collaboration and the sequence diagrams are the foundation for the integration testing. So once it is all set, once it is all ready with this level, only then it is possible for me to perform the integration testing is what you need to remember. So fine, then what is exactly the collaboration diagram gives me? My dear students, you need to understand collaboration diagrams. So this is what you need to understand. This is an example that I've taken here. Collaboration diagrams gives you a complete picture how exactly the message is being sent across the different classes that I have in the system. Here I've taken an example of calendar. So and I have I'm treating this as a different classes that I have in this system. And you need to observe all these things are the message being sent across the classes is what you need to observe here. So this is what you need to understand with respect to the collaboration diagram. So moving forward, what exactly that I have? When it comes to the pairwise integration, observe. When it comes to the pairwise integration, so where exactly this pairwise integration comes? Yes, we have something called call graph. So please recollect what we have discussed in the previous chapters. So fine, we have the call graph. Inside that we have 2 techniques. One is pairwise integration, another one is neighborhood. But when it comes to the pairwise integration, so we will be having 2 pairs, right? Is it 2 pairs? So please observe, I will have 2 classes is what I am treating. So one class is what I am treating it as a 1 unit. Suppose if I want to consider that class as a unit, so I should have 2 classes. One class should send the request, another class should send the response. Obviously, I should have 2 classes because this concept is what I will call it as a pairwise integration. When it comes to the concept of pairwise integration, 2 things I should have. It can be or it should be or it need not be 2 classes. It can be anything, but I am in this example, since it is object-oriented concept, I am considering 2 classes. So fine. One class is to send the request, another class is to send the response. So one class will be the genuine class, but the other class, what I have, that could be the stub. So that is what you need to remember. And developing the stub is a major problem which we have already studied. That is what the major point that you need to observe in this concept. Suppose if you ask me to give that different pairs, guys, here is an example that I have. So please observe, you have got multiple pairs. So I have the pairs for now class tested and date and with stubs for year. So here I'm treating the year stub as year. So for this again, I have a month and day. So day and year with the stub as tested. Like this, you will have a pair and for that I will be creating the stubs. You will have a pair and I will be creating the stubs. creating a stub will become a tedious task is what you need to observe in this diagram, right? So fine, moving forward to the next topic that I have here. All right, guys, one of the biggest drawback that I have basing the object-oriented integration testing on a collaboration diagram is that, so please understand, at the class level, the behavioral model of choice in the UML is state chart. So guys, state chart is preferred for a class level UML design diagram. That is the most important point that you need to remember. Sir, why do you call that as a drawback? So listen to me carefully. So guys, for class level behavior, if you want to understand the class level behavior, people are using the state chart. That is the most important thing. So state chart are excellent basics in the sense in a foundation or the beginning. So it is excellent for a beginning of test cases, and this particularly appropriate for the classes as unit choice. So that is what you need to remember. When I treat the classes as units, okay, if I want to know the behavior of a class, I will be preferring the state chart diagram is what you need to remember. That's defined in the UML. That's a most important point that you need to remember. And people treat this as a drawback. I will be coding why they are treating this as a drawback. Yes, moving forward, what is the next topic that I have? So guys, to an extent, the sequence diagrams are created. So I will be speaking about the sequence diagram with an example in detail in the coming session. But please understand, to an extent, sequence diagrams are treated as path. That's what you need to remember. So guys, what exactly the path is all about? So please understand, let me read the statement to all of you to make it very clear. To an extent, the sequence diagrams are created. They are reasonably basic for object-oriented integration. So fine, if they are saying that path is equivalent to the sequence diagram. So why are they speaking about the sequence diagram here? That is the most important point. So guys, let us understand this. Sequence diagrams are mainly used in the integration because whenever they are using the concept of object-oriented testing, they are treating the sequence diagram as path. It is equivalent to path is what they are trying to explain. So that is what you need to remember. Sir, what is path now? We have discussed that in detail in our previous chapters. Hope you know that. So thinking that I am speaking about this prod, no point. That's what you need to remember. Yes, of course, I will be speaking about this path in the next slide too, with respect to the object-oriented, right? Moving forward to the next point, they are nearly equivalent to the object-oriented version of path. That's what they need to remember. You need to remember, guys. So the sequence diagram, what I am using in the object-oriented integration, so that is equivalent to the path is what they are trying to say. All right, the actual tests for the sequence diagram would have pseudocode similar to this. So that's what they have given the pseudocode for a program. I will be speaking about this with the help of pseudocode in the next session. Don't worry about this. So the point that you need to remember is, so they will be using the sequence diagram. Sequence diagram is almost equivalent to the path is what you need to remember. But when they give the path, so we will be able to write the pseudocode. So let's understand that in the next session. So keep that in mind. So fine, moving forward, using the collaboration diagram or the sequence diagram as a foundation. So basis in the sense, the foundation for object-oriented testing leads to a lesser quality. That is one of the important drawback or the point that we need to understand. I repeat my point to all of you. So using the sequence diagram or the collaboration diagram. Sequence diagram will tell you the sequence, what exactly the next event is going to occur. So one by one, it will show you the sequence. But collaboration will give you the communication between the classes. So these two things will help me to understand what exactly is happening in the integration testing, but it leads to the lesser quality of integration testing is what you need to remember. So fine, moving forward to the next point, using the collaboration diagrams and the sequence diagram as a basis for object-oriented integration leads to a less quality is what you need to remember. So guys, then how do I improve the quality on integration testing? So let's understand that. So guys, remember, so collaboration diagram forces pairwise approach for integration testing. So that's a most important point that you need to remember. Whenever I go with a favor of collaboration diagrams, obviously it demands for the pairwise integration testing is what you need to understand. So if I want to have a pairwise integration, obviously I need to work for the stubs. So that could be the problem, is what you need to make a note there, right? Sequence diagram is a little better, but somehow the integration testers needs all the sequence diagram that pertains to the particular set and set of units to be integrated. So that is one more drawback that I have with respect to the sequence diagram. So fine, then how do I solve this problem? So guys, I have a concept called path for object-oriented software. When it comes to the path, so you all know that what exactly the path is all about. If I have a program, so guys, how exactly the execution is taking place in the program, and what is the path, how exactly from one function or a one module to another module the message is being transmitted for the execution, how exactly the control is going from one module to another module, so that I can represent very easily with the help of the concept called path. So it is giving me the feasible execution path of the complete program. So that is what I will be calling it as a path, is what you need to remember. So with the help of the concept of path, I will be able to write the pseudocode, is what you need to remember with respect to the object-oriented software. So guys, let's check what exactly I have with respect to the path. So an object-oriented path is a sequence of method execution linked by message. Sequence in the sense one after other. That is what you need to remember, which is linked. So please observe sequence of method execution. So how exactly the methods are getting executed from one after the other. So based on the message is what you need to remember. So that is what we are going to discuss with respect to the path. So fine, what is the second point that we have? path is a traditional software. We use message to transfer or invoke among the separate units or modules. What exactly the meaning of this point? I have the different modules, sequence of modules in the sense one after the other. How do I know that after this method or after this module, the another module should execute? So that will be decided by sending the message, is what you need to understand in this point. Moving forward to the next point, here we use the same acronym to refer the alternate sequence of method execution separated by message or message path. Method path is what you need to remember here. Moving forward, this is very important. So when exactly it stops, when the message reaches back to the same method, and if it does not react for that message and it does not send any more message, so there it comes to an end, is what you need to remember with respect to the path, right? Moving forward to the next one, the same thing that I have here, one more definition that they have given. I have two definitions for path. That's what you need to remember with respect to the object-oriented software. So guys, that's what they are trying to explain here. path is an object-oriented software, is a sequence of methods execution linked by messages. That's what you need to remember. How exactly the different methods are getting executed with the help of message is what you will get to know with respect to the path. And I have one more definitions with respect to the ASF, the same definition for path, right? And ASF is all about atomic system function, is what you need to remember, is an path that begins with a input port event and ends with the output port event. So that's what you need to remember here. So this is the two different definitions that we have with respect to the path of object-oriented concept. That's what you need to understand. And I comes to an end of the session. Guys, in the next session, I will be discussing pseudocode with respect to the path, and you will be knowing some more concepts with respect to the sequence diagram. So with this, I have come to an end of this session. In the next session, I will be coming back with a lot of interesting stuff. Till then, take care. Bye-bye.